Welcome to Planet Geo, the podcast where we talk about our amazing planet, how it works, and why it matters to you. Chris, we're on.
You know, do you remember when we used to get nervous? We would get so nervous when we would say, you remember that though?
Straighten up.
Back in the day?
Correct your posture and then come talk to me. There we go. No, I do remember that, Chris. I remember getting quite nervous, and at times we'd have to just like restart, or it'd be like, oh, we gotta have a drink real quick and then restart. Those days are long gone.
They are so long gone. There is no anxiety.
There are times when I get that sort of excited nervous when we have guests on. Especially guests that are,
absolutely.
I mean, we get some high profile guests, in our field, and there's an excitement, nervous, the sort of good butterflies that I get for those.
Absolutely. I still get that. That's a good point. That's a really good point. I just remember getting like really, really uptight is because we always talk, I don't know, sometimes a half hour, sometimes an hour, sometimes 5 minutes before we start recording. And then as soon as we'd hit that button,
the little red light
nerves, nervous. It's just really weird. And we would talk about like, are you nervous? Oh, I'm so nervous. I am too. What are we going to do?
What are we going to do? Oh my goodness. How do we calm down? I know for sure. Well, been a while. We've been going on 4.5 years now. I mean, we're old hats at it now, Chris.
I guess so.
Hey, real quick, nice thing that happened this past week is we got ranked as the #1 science teacher podcast on FeedSpot, which was a really nice acknowledgement. That was, that felt good, really was. Right? Yeah,
absolutely. It was of 2024, the top 25 science teacher podcasts you should listen to. And we were #1.
It was great. It was great. Really, really nice. To me, Chris, and I'm curious what you think, but to me, the primary validation that we get, I mean, we don't make money on this podcast, obviously. So the primary validation is really listener questions. And when listeners email us and say, hey, you guys have gotten me excited about going back to school or, re-pursuing this career in geology or I'm refocused in a new way, that's a massive fulfillment. And things like this are very nice too, to sort of have that external validation. But I'm curious what your thoughts are on that, like the sort of most validating parts.
I mean, to me, the most validating part, and this is going to sound totally selfish, is just learning what we learn and getting to talk to who we talk to. I feel like what I know now compared to what I knew 4 years ago, it's hard to quantify, Jesse.
I know.
It's really hard to...
It's as you often say, it's the best professional development that I've ever done.
100%.
And I think hopefully that comes across to the listeners that we're sort of learning at the same time. And in some instances, I mean, some of this stuff is sort of old hat, right? Like some of this stuff we know like the back of our hand, especially you've been teaching it for a long time. You know how to explain this stuff really well. But a lot of the stuff we go deeper, like this episode, Hardpan, we're going deeper than I'd ever thought about Hardpan really before. So we got to put the time in to learn about it and think about it and come up with good analogies for how to explain it, and bad analogies too.
That's absolutely, Jesse. Can we talk about where the idea came from?
Yeah, absolutely.
So living in Michigan, and there is a lot of clay in Michigan, and most of the clay it's not shale. This is residual clay. In other words, this was like material dropped off. It was the glacial kitty litter that covers Michigan.
Yeah.
And then over the last, 15,000 years, this stuff has weathered into clay in situ, in place. And so there's a lot of it. And it creates problems. I mean, it's my nemesis. I am so anti-clay in terms of like being a homeowner. It's really hard. It's very frustrating to deal with in terms of, for instance, basements, if you will. And I know a lot of our listeners don't. They live in areas where basements are not common. In Michigan, we have basements. And the clay presents problems for that because it almost invariably means that you have wet issues. You have moisture in your basement, or flat out, you're just wet. You have sump pumps and things like this that are going off all the time. But another issue is this hardpan that I have to deal with, especially as late spring and summer comes on. I've been doing a lot of yard work. We've talked about this. In fact, just before I came on here tonight with you, I was cutting trees in the back 40 again, and it's just been nonstop. And so when I have to dig holes, I get to this layer that I can't get a shovel through. And I have to go in And
can I interrupt you with a question here, Chris? Because this has been on my mind since you brought up this episode.
It now?
Yeah.
So okay, I can't wait to hear the question now.
So every once in a while, and it's happened a couple times in the last, let me say, month, where I'll be like, we plan when we're going to record these things. And sometimes it's late in the evening, like today. Sometimes it's, weekends or something. There's a while ago when I was like, hey, Chris, what do you got this weekend? Which day works to record? And you're like, not Saturday. I'm renting a backhoe or something like that.
I did.
Was this a hardpan exercise? Were you renting the backhoe for hardpan because your little weak arms, your weak old man arms can't get through the hardpan anymore, or what?
Okay. Yeah, my little delicate teacher hands can't handle the pickaxe anymore.
That's what I had in my head is that, I thought, Chris is getting old and he can't dig his holes anymore that he needs to dig in the yard.
So with the sheer quantity of trees that we've cut down, you cut the branches up, and we're making a natural perimeter on the border of our property. So I rented a Bobcat that has a bucket with a grappler on it.
Gotcha.
On the top end, it has these hooks that come down, and so I'm able to grab big, heavy, and a whole massive bunch of branches, and then just transport it where I want. So yes, I'm being lazy. I don't have to haul it.
This sounds like a rock collecting tool here. Bobcat, we need to get one of these and go grab some rocks with that sucker.
Yes, I know. It's a beast, and I love it. So yes, that's what I did. That's what I got going on. But
right, so it's not
back on topic. But I've been doing a lot of digging too. We're removing sod, redoing landscaping and so on. And I get to this area, it's anywhere from like 4 inches down to 10 inches, maybe even a foot down. And I can't get through it with a shovel. I'm reefing on this thing. I just can't do it. So I have to go into the barn and get my pickaxe out and start just going at it. So from that, this is the birth of this episode. What is hardpan? How does it form? And I think we can all agree that we hate it.
Yeah. And especially if you're a farmer or somebody who, especially in the Midwest and the West, these things happen. And so what this really is, hardpan, it's a kind of a colloquial term, but it's a dense layer, usually really, really dense, compact layer that occurs below the topsoil. It occurs somewhere in the soil horizon, and this varies depending on what type of soil you have in your area. Sometimes in the B horizon, typically. And we won't really go into soil horizons here. That's kind of the extent we'll get into soil horizons, but we'll come back to this analogy. Soil horizons are...
Oh, hold on, Jesse. Hold on. We do have a chapter dedicated to soils and soil horizons in our Camp Geo. The free online textbook. So if you go to the app, there is a whole section on soils. So
that's a great point. Great point. We've got some great images in there too that kind of show what these soil horizons are like. But soil horizons, water is always percolating through these things. And so they're what we call like an equilibrium phenomenon. So there is mass always moving through a soil horizon, but they're in chemical equilibrium. So although there's stuff being transported along it, they're meant to be sort of static chemically. If you take a snapshot at any one layer, think of like the atmosphere of Earth. There's molecules moving around in the atmosphere, but if you took a snapshot of the atmospheric layers, they're kind of the same composition most of the time generally. So it's kind of something along those lines. Anyway, that's as far as we'll get into soil horizons, but hardpan is one aspect of that.
It is, and it's a massive pain in my butt. But so I thought, well, this is geology, and this is relevant because a lot of people deal with hardpan. Farmers deal with this, people that do yard work. If you have the right conditions, hardpan is not an uncommon thing. Let's just say
That's right.
that.
Let me interrupt real quick there because it's one of these things that it's a sort of an everyday phenomenon for a lot of people, but it's also we'll end with this, it's deeply related to some very basic, very fundamental, very important geochemistry that happens on the planet. So we'll kind of end there that using and thinking about hardpan allows you to plug into thinking about things like the CO2 cycle on Earth and carbon sequestration. It's intimately related to that. So anyway, sorry for the interruption there.
No, that's good. Just some things to consider when you think about hardpan. You have this layer that's not very deep below the topsoil, just a couple inches in some cases. So tree roots and plant roots, landscaping things that you put in there have a hard time. The roots can't penetrate that hardpan. And so you either can only grow trees that have shallow root systems, or you try to grow trees that you shouldn't grow there. And then because of their shallow root system, they just sprawl. And then these are going to be typically easy to blow over. These are wind blown over trees. And this is, I think of the pine trees in my backyard. This is an ongoing issue with me for sure. I always think of Yellowstone National Park when I think of this kind of thing, where roots have a hard time penetrating into this hardpan kind of like layer. I think of Hayden Valley, this famous valley where the bison hang out, the elk hang out, the bears are there. It's a really, really awesome place, but it's not technically hardpan, but it's very similar, where this is old lake bottom sediment that essentially formed a hardpan. And so the roots from these lodgepole pines that are all over the place in Yellowstone, they can't take hold in Hayden Valley. And so it's just grass and sage and trees just can't grow there, and it's very similar to what I have going on here in, Southwest
at the
Michigan.
Bullheis household.
So, you got that right. Another problem at the Bullheis household.
At least while you're worrying about this and stressing about it, you get to think of Hayden Valley and Yellowstone National Park. That always is a nice thing to think about, right? So hardpan, other problems that are associated with this is it's really a thick, impervious layer. So water can't penetrate it. So if it's really shallow, like yours, Chris, the layer above it during rainfall can get super saturated. You can flood more easily. However, during dry spells, plants can't tap their roots, as you said, through that hardpan layer, so it gets dried out much more easily too, because roots can't penetrate down and tap into that deeper, more stable water source deeper into the soil. So it's a huge problem in farmland. It's also a problem in drain fields. Drain fields, if you have like a septic drain field or something, this can cause failure because this hardpan layer kind of, is impervious and prevents fluids from flowing through it. So there's all sorts
or the drain field stays on the surface.
Exactly. It doesn't.
And I have this running
down
through my backyard. I got the drain field from my neighbors ways away, and it can't leach through and penetrate down below the hardpan.
So it just runs off the 4
surface.
inches
Absolutely.
beneath the surface
Constantly.
And then flows out, down in your little sort of gully you have back there. So
it's kind of like permafrost, Jesse, if you think about it, right? In these tundra regions where you have this permanently frozen pore space in the soil down below, water can't penetrate. It's impervious to ice. Ice won't let water travel through it, and it's a lot like this. And so it's that upper area easily gets saturated, which then causes solifluction. This is a very similar scenario to that. Actually.
That's right. That's exactly right. The sort of repercussions of it are very similar. So we're going to differentiate between natural and human-induced hardpan here because there are multiple ways to produce hardpan. Let me just run through the human-induced ones because we're not really going to focus on this, and they're kind of, I think, obvious. Human-induced ones are typically soil compaction, especially with heavily plowed farmland. So if you keep plowing and turning up the soil and then running, heavy equipment over it, heavy tractors and things like that, eventually that soil gets compacted, and you can actually kind of have a sorting mechanism which will move the clay particles, we'll talk about that later, down to the bottom level, and they'll get really compacted, and you'll create what they call a plowing induced hardpan just beneath sort of the plowing layer of the field. So this is a major problem. It has all the same sort of implications that we just talked about. So those are kind of the human induced ones, are typically farming practices and driving big vehicles around it.
Yeah, driving the big vehicles around it. And then, because you're constantly churning up and tilling up that upper few inches. But you have the heavy vehicles too, and you're compacting the layer right below that.
Exactly. And anytime you kind of churn stuff up, you have the tendency to sort stuff, right? So if you kind of take a big handful of dust and sand, you throw it in the air, the dust will stay and the sand will fall to the bottom. The same thing goes on at a much slower pace when you churn up soil. So the natural processes, I think, Chris, are more what we're interested in focusing on here. How does hardpan form naturally?
Yeah, I actually want to ask the listeners a second before we delve into this. Like, what do you think about soil pH? In other words, the acidity or the lack of acidity of the soil, and what might favor the formation of hardpan, which we don't like. If we just think about that a second, I don't know, right? That's a fair question, right? I would ask this to my students. What do you think in terms of, all right, we want to form this really densely packed layer below the topsoil, and soil pH plays into this equation.
I mean, to me, Chris, in my class, I'd get a lot of blank stares. In part because I'm moving through this quicker than you do. In your class, you have a year, and you go a lot deeper, actually, than some people might be surprised at this. You go deeper than the college class does. But,
all right,
for me, I'd get a lot of blank stares.
Jesse, and so I probably would too if I asked it just like that. And then I would say, okay, wait a minute. Hardpan is going to this really, really densely packed layer. What's going to favor that? The leaching of stuff from the top, or the lack of leaching stuff from the top, right?
That makes sense.
I might ask that. Or what's going to favor putting elements and compounds in solution? What's going to dissolve things easier? Low pH soil, in other words, acidic, or high pH soil, in other words, basic. Then I think that you'd get a lot less blank stares, don't you think?
No, I think that's absolutely right. And I think acidic soil, that just, people assume acid as reactive. So I think that makes intuitive sense that an acidic soil is going to exactly do as what you said. It's going to react more. It's going to leach more stuff from the top and deposit it at the bottom. And Chris, what analogy do you use to describe that leaching and depositing system in soils? Do you have...
I always think of a coffee pot. I mean, that's a perfect example of leaching. You have these coffee grounds, and then you pour hot water through it, and it just sucks out. It takes what it wants and then leaches it out of the coffee grounds and puts it in solution and puts it in your coffee carafe, right?
All the good
I think
stuff.
that works. Yeah, right, exactly. So if you have soil then that has a low pH, in other words, it's quite acidic. And a lot of times, Jesse, to be honest with you, that's pretty counterintuitive. A lot of people think, acidity, very reactive, it's going to have a high pH. It's actually the opposite. The lower pH, the more acidic something is. Do you find that to be true?
Yeah, I agree. That's a source of confusion for students for sure. Yeah.
So let's think about things that might be in the soil then that could get leached out. And so you think
hold on,
about
Chris, let me interrupt you here real quick because...
Yeah.
This is something we've talked about this before. We've talked about this type of stuff a lot. Go back to our Earth's Climate book. We've talked about the silicate weathering cycle. What are the types of things that get broken down by chemical reactions, which are acidic, and a lot of that acid is bicarbonate, which comes from CO2 into water. A lot of that acidity is going to be bicarbonate. What is that going to react with, right? Think about that. We've talked about it before. The things people should be coming to mind are like carbonates, calcium, magnesium, some iron, perhaps, depending on the oxidation state. Silica.
And when you say carbonates, Jesse, you're referring to minerals like calcite. If there's limestone present, things like this, right? Those are highly soluble. Think about this a second, right? If you've ever been in a cave, that cave is dissolution of limestone in one form or another. That's a rock or a mineral that is highly susceptible to being put in solution by acidic water. And so if you have carbonates, calcite, limestone in your soil, the little tiny pieces, and the tinier the better, because then it's easier for them to go into solution. You said it too, things like iron oxides, and even to a lesser degree, the silicates, things like quartzes, right? Those will go into solution, but to a much lesser degree. But you have these things, those can get leached out, and then they will be precipitated down in this clay-rich layer that gets compacted into hardpan down below.
So, Chris, let me just jump on that point real quick, because this is where we have to come back to the coffee pot analogy. And this is where I find the coffee pot analogy is a little bit of an imperfect one, because, in the coffee pot, it goes in liquid and then it just goes in our stomach as liquid form. But imagine if you left that coffee pot, or sometimes, I don't know, we always do this at our house. There's always a little bit left in the coffee pot, bottom little bit, and we go on vacation and forget about it, forget to clean it out. You come back and the water's dried and you have coffee residue in the bottom of your carafe. It's kind of some effort to get that back out. That's more like what we're talking about, because as that water is percolating from the topsoil, the very top part, it's leaching a bit. As it leaches out, the chemistry changes. So as that acid dissolves metals and ions, it actually decreases the acidity of the water. So the water is actually kind of changing its own composition. Then it's going down, it's interacting with organic material, it's changing oxidation state. Like there's a lot of soil chemistry that happens that changes in the first couple inches of a soil horizon. So as it goes down, it can all of a sudden start to deposit these things, which is what you're referring to. It gets down into this kind of clay layer. And then all those elements are forming calcite and magnesite and all this cement that can bind grains together further on down the soil profile.
Right on. And so in addition to pH and acidic water or acidic soil, if you have clay, it's going to play into this. It's kind of like this positive feedback loop because clay is very impervious, right? Clay's impervious. And so if you have this leaching that's taken place and drawing these dissolved chemicals down, and then the water sits in that clay or on top of the clay, and then you go through a dry spell, the water evaporates and it kind of binds the clay together and makes it even more impervious and more hardpan. So it's this very interesting positive feedback loop that you get between soil pH and a clay-rich kind of soil to begin with. You got the makings for a very annoying hardpan.
And if you're listening to this, can you tell that Chris is frustrated by hardpan yet or not?
I just came in from outside. I'm really upset.
But so Chris, you touched on this clay thing, and this clay is really important because clay is a group of minerals. It's also, a grain size, but it's a group of minerals.
That's going to be an episode coming up, Jesse, actually. What is clay?
Hey, episode segue word there.
Stay tuned.
But clay, stay tuned. Clay is this group of minerals. They're very flaky. Think of them like micas. They're this really flaky thing. So the thing about clay is that it's really easy to make a really compact sequence of soil out of clay. Why? Well, because if you have flaky stuff, you can compact that. You can lay those layers flat on top of each other, and they're also quite easy to bind together. They have a little bit of polarity to them, so they can bind together really easily. And so I always use the analogy, Chris, of quartz. Quartz is like a marble. So if you dump a bunch of marbles into a bucket and you shake it up and shake it up and shake it up, they might settle a little bit, but you're still going to be able to pour water through that bucket, through those marbles pretty easily. Now, if you take clay, I always use the analogy like leaves, then this is probably a bad one. I bet you have a better one. So tell me about this.
No, I actually think this is a really good analogy. I think it's awesome. Go. Yeah.
So you're raking leaves, right? And in our neighborhood, you either blow them out into the street and they come pick them up, or you put them into bags and then set those on the street, right? But if I always dump leaves into a bag, you dump them in there and it's not very compact and it's always frustrating. It takes up so much space. But if you shake that big leaf bag a whole bunch, you can get those to compact pretty well. And you can actually, if you push them down, they can lay flat on top of each other and you can get a pretty dense bag of leaves that's pretty heavy. It's hard time lifting that up, right? And so that's what I kind of think of for clay minerals is if you lay clay minerals flat on top of each other, and this is what happens in like an ancient lake bed, like Hayden Valley, ancient lake bed, when those clay minerals are depositing out, they're laying down flat and flat and flat. And so that makes a really, really impenetrable surface. The same thing goes when you're plowing a field. If you plow it up and then compact it down, plow it up, compact it down, those clay minerals are getting stacked right on top of each other. And that's really, really easy to make to start this feedback loop of hardpan as you described.
That's right. And not to get too in the weeds here, Jesse, but what you're describing is the silicate structure of the clay mineral itself. It's a sheet silicate, and I think most young students think about sheet silicates and they automatically think of biotite and muscovite and micas. Well, that's good and that's accurate, but clay is just like that. Clay is that flat sheet-like mineral that you described beautifully when you're talking about like the leaves in a bag. And when you compact them, the leaves orient themselves. The flat side is perpendicular to the direction of compaction. And so you get this really, really compressible hardpan layer due to the silicate structure of clay minerals. So yeah, that's absolutely right. So Jesse, that leads us to the next thing. what can you do? So if you have Hardpan, like me, okay, what and you have teacher hands like Chris Bullheis, what do you do?
If you're like Chris Bullheis, what do you do? Well, you go write a script on Hardpan and then you complain about it to your podcast audience for a while. I think so. There are some solutions that I think are probably obvious, right? That we've talked about. So we've talked about acidity. You can do things to decrease the acidity. And one of them is adding lime, CaO, adding lime to your soil, which is something that farmers do a lot.
They absolutely do. But I want to push back on you, my geochemist. So this could seem counterintuitive because we talk about limestone and calcite as being highly soluble substances that get leached out of acidic soil and brought down to the hardpan. So adding lime, how is that going to help? We said that's part of the problem.
Well, you're adding CaO and then you're decreasing the acidity because the CaO reacts with bicarbonate. We've talked about this before with the dissolved CO2 ion or the dissolved version of that, which is acidic. It reacts with this and decreases the acidity of the soil. And so then it'll keep this calcium carbonate now up in the upper part of the soil horizon and not forming down in the hardpan down below where you don't want it to form.
Right. What I was getting at, Jesse, is that a lot of people think lime and limestone are the same thing.
Yes. Okay. Right. Okay.
That's what I meant by that. The word that can lead to confusion. And it's really not. It's a slightly different chemistry that's going on.
That's exactly right, Chris, and that's a great point. Lime is not limestone, and this is something that's quite confusing. Limestone is a stone that's made of lime, and so you have to add the stone part to it, which is the CO2 part. And this is really an interesting thing because we've talked about this in our book on Earth's climate. So go to the Camp Geo app, and you can buy access to that for a couple bucks. We talk about this aspect that this process, this adding lime to decrease soil acidity, there are really interesting solutions to climate change, to CO2 increases that people are proposing. That is, instead of dumping lime on your soil, dump crushed up basalt onto your soil, which will help draw down CO2 while decreasing soil acidity. So you can help, fight this hardpan thing and pull CO2 out of the atmosphere. It's kind of a win-win. So anyway, that's part of a more complicated thing we won't get into here today, but you can find that on our Camp Geo app where we talk about that. It's a really, this process is just really important. This one reaction that we keep talking about here.
So just to be clear, before we move on, because we're going to move on here, but lime is calcium oxide. It's CaO. And limestone is calcium carbonate. It's CaCO3. And so they're very, very different and result in different things. So bottom line,
exactly right.
Adding lime, calcium oxide, to your soil can reduce the pH and therefore reduce the ability of that water to leach carbonates out of your soil down to the hardpan. And other things too, like iron oxides and silica and so on. Another thing, Jesse, too, that you can do is add organic matter. And this is something that I'm trying to do a lot of, actually.
Oh, is that right?
I don't know if you know this about me. Yeah. A number of years ago now, I built a pretty large composting series of bins in my backyard. And so we're trying to generate as much topsoil as we can, or soil that I can use in the gardening area then. And the way composting works is you use these organisms to decompose things. So when it's all said and done, you have this really organic rich soil. And then you just dump it into your holes and use it as topsoil. And that process then just continues on its own. And these burrowing organisms will then break up the hardpan in a natural sort of way. So that's something that I'm trying to do.
I mean, that's something that's really impressive is like how much worms and other creatures are good at breaking this stuff up, given enough time and given the right nutrients that they need. These solutions here can get really complicated really quickly. And this is why, the modern farmer is really a geochemist. Soils, and I know not a lot of our listeners are going to be geochemists, but some of you will have used like cation exchange resins or something like this to do chemistry with. And soils are very much like that, where if you pass fluid through them, you're going to get a bunch of different elements off at different times and different compositions with different types of fluid going through it. So it just gets really, really complicated really quickly. But one thing, Chris, that I sort of maybe newly appreciate, back to our conversation at the beginning here, is that the additives that farmers put on their fields are not just, fertilizer to help the plants grow. A lot of it is actually about soil structure and about fighting hardpan and doing these sort of long-term things to suppress hardpan development that are actually adding structure to this. It's more about the soil structure and the soil horizon development than it is about adding nutrients for one plant to grow.
I got to ask, where did you come across this in terms of the complexity of what farmers are adding to not just help the plants, but help the soil itself, the soil chemistry, soil pH, all that?
Oh man. Well, Chris, you know this.
You're not a farmer. So, is this something that you just came across, or is this a part of your background? That's what I'm asking. Does that make sense?
This is one of the rabbit holes we go down when we're making these episodes, right? I got down the rabbit hole of okay, what are the solutions to this? People add lime. Okay, what else gets added to soil? And it's these
and then your mind goes in a lot of different.
Oh yeah, and then you're like, wait, that's cool. I got to learn about that. So yeah, this is one of the rabbit holes related to this episode that I went down, to be honest. So, but I think, you're doing similar stuff with your composting, right? It's just, there are these solutions that people do to fight this.
I love not only can I fight my hardpan, which I've been dealing with for a long time, but I had a hard time with the idea of, Jenny and I eat a lot of vegetables and fruits and things like this. And you deal with the cores and the skins and things like this. And we eat this stuff daily. And so the idea of throwing it away in the garbage just didn't sit right with me. And so I also burn wood. And so I have a perfect source of carbon to mix with my organic material. It's just the perfect scenario, actually, to just go ahead and compost. And I like the idea of it. It is. And then I get to use it. And it's very satisfying when you go to the compost bin and you fill up 3 wheelbarrows of your own dirt that you made, that's very, very organic rich. It's awesome. I love it. It's just fun.
Chris, I think you made a mistake. You said wheelbarrows there instead of your rented tractor so that you don't have to get your hands dirty.
I have a confession. I bought a tractor this past weekend.
When? This past weekend you did?
I did.
Oh, please. Okay, here's what I want, Chris. You go, next time you're using it, take a photo of Chris on the tractor. We'll post it to the social media profiles. We have to have Chris on his tractor. Was this a granite countertop purchase? You talked about it and then did it kind of a thing?
It was. I really had to convince Jenny. It took a long time. I've been on this for a while because our property, we need this. We just have so much going on. And I'm getting old. And
was that the pitch? Jenny, look at me. I'm getting old, my dear.
I'm getting decrepit. I can't get out of bed.
Jenny, save my back and my knees.
We just...
Okay.
It's not
exciting.
It's a subcompact tractor. But we still need to rent the Bobcat with the grappler because that just is a beast. It's a whole different level
it's too much fun
of work. Oh my gosh. I look forward to it so much.
Of course you do. Chris,
I get up at 5 a.m.
Listen, Chris, I know. Because you know what? I've been like, Chris, let's record today. I can't. I rented the tractor. I couldn't possibly. I'm. It's you'd imagine that you were getting married or something that day. What you're scheduling?
It's so much fun. Yeah. Today, I didn't.
That's great.
I got home before Jenny, and so I got on my tractor and drove out to the end of the driveway to meet her. That's how excited I am.
That's pretty good. Okay, we need a photo. Everybody wants a photo of Chris Wallace on his new tractor. Okay. Before we end this episode, you son of a gun, I called you the other day and you were on the way to or back from the John Deere and you didn't tell me you were buying a tractor. You just said, I'm going to run some errands at the John Deere
you know what?
place.
That's because I got a flat tire in it.
Oh.
I had already bought it. And
you and your
I got a flat tire.
Man.
So so I took the tire off. I couldn't do it. You have to take the tire off the wheel to replace it. It was a bad valve stem. I replaced the valve core. And anyway, long story short, that's where I was then. I'd already bought the tractor. I got,
okay.
Yeah, I used it for like a half hour and got a flat tire. It was very disappointing.
We just need somebody. I mean, you're between the flat tires on your bikes and your tractors. We just need like a permanent tire repair person to be in residence at the Bullis household.
Oh, that's right. My bike. Yeah. I know. It's a good point. It's a very good point.
All right. Well, Chris, I like this episode. Hardpan.
This all goes back to Hardpan.
Everybody, it's something that people run across frequently. It's one of the everyday things. And when you're thinking about Hardpan, you can think about how clays behave, how the CO2 cycle works, glacial lakes forming, all sorts of fun geology, all right there in Hardpan. And, soil as your coffee pot. That's a pretty good one. So, hey, there's 2 ways to support us. We don't really care which one you do as long as you do one of them. Go to our Camp Geo app. You can download that. It's the first link in your show notes. You can go to our website. That's planetgeocast.com. There's a support us link there, and we always appreciate any support you can provide. Send us an email, planetgeocast@gmail.com. We love hearing your questions and hearing, what stood out to you from various episodes and what your thoughts are. So send us an email. We love that. Also reach out on any of the social medias. We're at Planet Geocast. Thanks for listening.
Cheers.